Hi guys, Buildzoid here, and today we're going to be taking a look at a rather extreme memory overclock that I've been able to achieve on these Teamgroup Tforce Xtreem ARGB memory sticks on the Gigabyte B550 AORS Master along with my 3700X. So the Xtreem ARGB kit that I'm using here, and I have two sets of these sticks. Man, my English is great. Like the way I just said that sentence is weird. If you just don't think about it. Anyway, that's for me to worry about. Anyway, so the spec on these kits is 3600, 14, 15, 15, 35 at 1.45 volts, which tells you right off the bat that this has to be Samsung B-Die because TRCD 15 at 3600 megahertz is not happening on anything other than Samsung B-Die. So, yeah, it's Samsung B-Die. And also 3614 at 1.45 volts for Teamgroup specifically is, I think, one of their top memory bins. Like, I'm not. I think they have a couple speed bins that might be about as aggressive or slightly more aggressive, but basically for Teamgroup, this is a top bin of B-Die right here. And actually, relative to the rest of my memory collection, these sticks are ever so slightly better than my previous best sticks. So yeah, it kind of shows. Like these are really solid as far as the two kits that I have, and they're actually really far apart in serial numbers. I didn't get two sets that are like super close together because I got one set and then I got another set like a month or two later. And they are review samples from Teamgroup. I forgot to mention that. So thank you Teamgroup for sending them over. I should. I'm sorry about taking so long to actually get around to making a video with them, but yeah, the thing is, I wanted to do something. The thing is, these memory sticks are kind of a workout for my memory controllers, and I didn't want to do basically the same settings that I've done on other sticks with slightly less voltage, which is basically what, it tells me that these are somewhat better. Anyway, yeah, so really great Samsung B-Die. And then I guess it's worth noting because I think when people first saw these DIMMs, there was a lot, like at least I saw some concern for the fact that the entire, like most of the memory stick is actually covered in the RGB diffuser for these, which I think it looks great. I think these are some of the prettiest memory sticks out there. Even lit up, like turned off and lit up. The only issue is their fingerprint magnets. So for me as like benchmarking memory sticks, they're kind of annoying to work with because they get all, their fingerprint magnets. But anyway, so you have this massive RGB diffuser. And the main concern with that is, well, it's made of plastic, right? And plastic, as we all know, is not particularly great at conducting heat. So the concern with these is, of course, like, don't these have like thermal issues? And I tried to get these to overheat by basically roasting them with a hairdryer at XMP, because once you start overclocking the memory sticks, it's like you take once you start overclocking, you can just push the settings until they need 20 degrees ambient to function or something, right? Or you need the sticks at 20 degrees in order for the settings to function. So that's kind of the thing. Like, it's part of the reason why I have a fan on the test setup here, right? Is because the settings I'm running right now, yeah, they're very temperature sensitive, but with these sticks just running at the XMP speed, you can get them all the way, like, over 60 degrees, and they're fine. They don't care. So that's pretty cool. Though I'm not sure. Like, the thing is, overclocked temperature tolerance really, like, it's not so much about your stick. Like, it's to some extent it's about the memory stick, but it's also like how far did you push the settings, right? So if I push these to higher settings than a different kit that I have, and then I do a thermal like stability test on them, and these fail at a lower temperature, it's like, well, it might be because I'm running them at a higher setting. So that's kind of something that you can't really test for, but at least at XMP, I can't see, like, I don't know how you'd get these to overheat. I guess maybe if you had 4 of them together and then had a really high ambient room temperature, you might run into issues, but even then, it's like, you'd need to get them over 60. Right? Like, because I didn't actually ever get them to error. That's the thing. Like, my hairdryer doesn't get hot enough. So, yeah, anyway. So that's kind of the heat spreader situation. And the thing is, like, they're not plastic all around, right? You have this little aluminum heat spreader on the back. I don't really think this back part actually does much, because it doesn't really change the overall surface area of the memory chips that much, right? It's not that much. Like, if you've seen memory chips, they're basically, yeah, I don't think it necessarily does that much, but they don't seem to have any thermal issues on the XMP, so I wouldn't be worried about that. Now, The PCB that these memory sticks use is a A2 PCB layout with the extra capacitors, which if you don't know which capacitors I consider the extra capacitors, here is a what I consider vanilla A2 well, a normal A2 PCB for comparison. Well, I say normal, but like a normal A2 PCB would be green and less layers, but yeah, so that's an A2 layout right there, and you can just see the memory chips, right? One group over here, one group over there. And you can't see that on this stick, even though the chips are in the same locations, because there's capacitors in front of them. Well, you can kind of see the chips behind the capacitors, but there's capacitors in front of them. So yeah, it's the A2 layout with the extra capacitors. I wish I knew, I wish I had a better name for it, but I've had other kits with this PCB, and it just so happens that all of the best memory sticks I have use this PCB, or at least have a PCB with the extra capacitors. Technically, these also have extra RGB like driving circuitry on them because of the RGB. Like my other kit with the A2 and extra capacitor, like A2 layout with extra capacitors, doesn't have any RGB, but that ultimately doesn't make much of a difference. That there's plenty of empty space on an A2 memory stick to whack as much RGB circuitry into as you would like. So yeah, that's the sticks. Let's take a look at the actual overclock. So I do have them on the B550 Master, and there's a small chance this is going to up and die at any moment because there's the BIOS version that I'm currently using has a annoying issues with Infinity Fabric overclocking. So yeah, anyway, from the title of the video, you should already know that the memory overclock that that I've been kind of teasing here for no good reason is 4800 CL15. Which on Ryzen, you might think, wait, 4800 CL15? How does that even work for multiple reasons, right? Like, why would you even want to run 4800 CL15? You're outside of the synchronization with the Infinity Fabric because you're all the way up at 4800. But it turns out that if you tighten up the timings enough at 4800 megahertz, it actually performs really, really well in Geekbench. Now, I'm not sure if this translates to real-world workloads, and my favorite representation of a real-world workload is a very unreal, is a LinPack, the stress test, because it hammers the memory, it scales with memory timings, it scales with memory frequency, it scales with memory ranks, it scales with everything. It's great. The only issue is we can't run LinPack on this because it'll crash. Like very quickly because this is right on the ragged edge of stable. Well, actually, I'm not sure it's on the. It's actually relative. It's not as bad as some of the other memory overclocks I've done in the past. But yeah, like this, it's not going to run LinPack, but it does finish Geekbench and it spits out an absolutely massive score of 9,842 points. Now, if you don't know, like the thing is, I'm actually still disappointed with that score, and it's not the memory stick's fault. It's kind of my fault, kind of the motherboard's fault. So the motherboard doesn't go over 2 volts on the memory, and I ideally want to be able to hit 10,000 points. But yeah, that's not 10,000. That's 150 points down from 10,000. So yeah, that's why I'm kind of disappointed, but it's still an absolutely massive score. For as far as I'm aware, on ambient cooling, 10,000 points memory score in Geekbench 3 is basically around the limit for what you can do on Ryzen. Anyway, what's crazy about this is that Geekbench, like if you're running 3800 CL12 like super tight, you're probably going to be looking around somewhere around like 9,000. So the crazy thing here is that, 4800 desynced is actually just faster than like 3800 super tight timings synchronized. And okay, the system didn't crash. My mouse is just being derpy, which is honestly like if you're having weird like USB cutouts or audio issues, that's actually Infinity Fabric instability a lot of the time. So if you've overclocked your Infinity Fabric and your peripherals are being weird, it's because it's unstable. Anyway, so let's run the cache and memory benchmark. So Geekbench loves this overclock, and that's kind of the main purpose of these settings is just like smashing the Geekbench memory score because Geekbench is an actual like if you're into benchmarking competitively, Geekbench is just one of the benchmarks that you bench on HWBot. And getting a big memory score is part of how you get a big overall score. So yeah, anyway, the thing I find most crazy about this overclock, though, is the IDA results. So, that's the wrong button. The hell? There we go. So read, we're getting 56 gigabytes per second, which honestly isn't that impressive. Write speed is limited by the fact that we're on a single CCX CPU, right? The 3700X has one, actually not single CCX, single CCD. We've got a copy speed of 58.5 gigabytes, which I think actually is pretty decent, but I can't, like, it's been a while since I've run like a bunch of IDA benchmarks on Ryzen. I think the upper limits are generally around 60 gigabytes per second on every single test. But the crazy thing is it's getting 64.3 nanoseconds of latency, right? And we're out of sync. We're desynchronized memory from the memory, like we've desynced the memory from the, desynced the memory controller from the Infinity Fabric, and yet we're still getting like low 60s on the memory latency, which is absolutely insane. So yeah, you can just kind of like if you've got good like really good Samsung B-die, you can brute force performance at high frequencies to some extent. But this is again primarily for benchmarking applications, because in order to get these settings to run, you can't have the full memory sticks addressable. As you can see, I have Windows restricted to only 2.6 gigabytes of memory. And the way you do that is you get msconfig, right? Oops. Oh, come on. There. Go to msconfig and go to the boot menu. And then if the mouse would stop glitching out, that would be great. And then you go to advanced options and then you set your maximum memory amount. Now the thing is, this is actually a bit glitchy on Windows 10, so you might have to like fiddle around with the value a few times before you get the memory capacity you want. Like right now I have to, though it generally works, like at low amounts work fine, but if you're trying to hit like 4 gigs available, which for certain settings or certain benchmarks, you might need 4 gigs of memory or 8 gigs of memory. When you're trying to restrict it down to like 4 gigs or 8 gigs, it gets kind of annoying because you punch in a number and you don't actually get the, like, for whatever reason, Windows 10 doesn't restrict the memory as much or as little as you tell it to. So you get a like past it, like at certain values, the memory restriction is kind of random. And there technically is like a command line command that you can use that's way more accurate, but I'm too lazy to remember that command. So I just sort of, well, actually, it's not like I just do it through msconfig, which is not the most efficient way of doing things, but it works. So anyway, let's take a look in the BIOS to see the magic necessary to make this work. And most of that is actually just getting a good motherboard and a good memory kit and a good CPU. Well, actually, I'm not even sure that you need necessarily a super great memory controller, though admittedly the 3700X that I'm using here does have a better memory controller than all of my other Zen 2 CPUs. So I'm going to assume that the memory controller on it is at least average, if not more than if not better than average. Because I kind of find it unlikely that I have 3 CPUs with terrible memory controllers. Anyway, so here's the settings. Now, the 3700X, so this is the chip I complain about how it's degraded and how it sucks and how it sucks. So it's at 4.3 gigahertz right now, but the trick to that is that it's actually not I have no SMT. We're mashing way too much voltage into it. And this is probably part of why it's degraded. Anyway, and it's probably going to get worse if I keep using it this way. SoC voltage is at 1.2 volts, DRAM voltage at 1.97. This is part of the reason why you have to restrict the available memory capacity in Windows. If with Samsung B-die, once you go past like 1.75 volts, if you allow Windows to try address all of the memory, it just blue screens. And I'm not sure why it does that, but there's like a stability problem that kicks in with the whole memory sticks being available. So when you're at high voltages, you need to like the higher the voltage you're at, the more you need to sort of restrict the available memory, though sometimes you can just kind of give up on some settings. So anyway, 1.97 volts on the memory voltage, VPP auto and VTT DRAM termination also auto. These DIMMs actually tolerate pretty high termination voltage just fine. So yeah, we can leave that on auto. You might be looking at the 0.6 volts right here. That's wrong. It's not actually at 0.6 volts. The way the circuit works is if you're on auto settings, it'll take your DIMM voltage and divide it by 2. So right now, the actual termination voltage is going to be 0.935? No, 0.985. Yeah, 0.985 millivolts. I mean volts, not millivolts, off by 1,000. You know, so 0.985 volts. And depending on your sticks, actually, like the thing is, a lot of sticks will actually require like lower voltages once you're at high dim voltage. So I have a lot of kits where if I was running 1.9 volts into them, I would need to restrict 1.97 volts into them. I'd need to restrict the termination voltage down to like 0.92 instead of 0.98. And that actually makes a pretty big difference to the stability, even though it doesn't sound like much of a difference. But these sticks right here tolerate high termination voltage just fine. So there's no reason to do that, so I can leave it on auto. Anyway, then CPU VRM settings, we just have high LLC and then everything else auto. Let's take a look at the advanced memory settings. So the timings are 15, 14, 8, 12, 24, 36, 10. So these, none of the primaries go any lower. Generally speaking, when I said Geekbench can technically do, like you can technically get like a 10,000 memory score in Geekbench on ambient cooling, generally the settings used for doing that kind of thing is like CL14. And these DIMMs can do CL14. They just need more than 2 volts to do it. And this motherboard, unfortunately, tops out at 2 volts. And I could hard mod the board to have more voltage range, but currently I don't have like I can't like I don't have the. Let's put it this way: there's a bunch of junk in the way of me being able to use my soldering stations, so I can't actually mod the board because my equipment isn't available to do that. Though it is something, actually, there's multiple things I want to modify on this board eventually, because it's really good at memory overclocking, but it's got a really stupid dual BIOS implementation, and then there's the memory voltage not going high enough. So, yeah, we need to fix that. Anyway, for the rest of the timings, TRC36, I think it might go lower, but generally it's best to keep it in lock, like TRP plus TRAS equal to TRC generally gives you the best performance. And usually if you can lower the TRC below your TRAS plus TRP setting, you can also just lower the TRAS or the TRP anyway. So you should just kind of like, there's really no reason to have these not be equal, like 12, like the 12 plus 24, there's no reason for me to, like if I wanted to run, if I wanted to run 34, I would probably work like that. Actually, this might even work. So yeah, those might be some of the timings that I didn't completely minimize, but anyway. There's not much headroom left in those. TRP isn't going any lower, so at this point it's just TRAS, and I believe the memory controller does not support values lower than 21. Yeah. So, you know, that's another consideration. There is just like, the minimum TRC I could run is like that. Anyway, so we'll go back to that. TWR literally doesn't go lower. If you try to lower it anymore, it just goes to auto, which is worse. So minimum value 10, minimum value, we could try 9. I have my doubts about it being stable, but might be worth trying. That's one of the ones that might actually, you know, lead to some performance gains. TRRDS4, TRRDL4. I mean, 5. I think 4 would probably work. I don't think it would do much to the performance. So, yeah, it's basically maxed. I tried 3. 3 does not work. Not at this frequency. 3 was super unstable. I think it doesn't even train, maybe. So, yeah, that one's basically maxed. WTRL, 7. I tried 6. 6 wasn't very happy, so that's kind of that. 270 for the TRFC. This might still go lower, but that also really depends on your sticks. Like, some sticks will need TRFC 300. Some sticks will potentially, at this frequency, you might find some kits that go all the way down to, like, 220. And the thing is, also, it depends kind of on what memory voltage you're at. So with slightly more memory voltage, you might be able to push lower TRFC. But again, like, the board's basically maxed out on memory voltage, so can't do that. These two on auto because they don't do anything. RTP at 8. I tried 6. 6 doesn't work. And, well, there is a 7, but I don't think it would make too much of a difference. Tforce 16. So the funny thing about Tforce is you can technically set it lower. It's just if your TRRDs, like if your TRRD is 4.5 or 4.4 or 4, like whatever TRRD is your lowest restricts how small the Tforce can be. So I could set Tforce 12. It just wouldn't make a difference to the overall performance if I did that. So there's no reason to do that. Anyway, so Yeah, like also it wouldn't affect stability. Like you can set TFAW as low as you want, and it just doesn't actually do that. These are all 1 because they literally don't go lower than 1. These are on auto. Oh, this one's on auto, and actually right now it trained really loose. Like a lot of the time that one should be at 13 instead of like 15, 14. But the thing is, at the same time, there's like training issues with that, so I'm not going to fight it. Like if it decided to boot 15 right now, then 15 it is. I have no intention of trying to make this like the system. Like at this point, it's so on edge that yeah, that's like it could technically be lower, but it's just like I like it when it runs instead of when it doesn't post. So SCLs don't go any. Actually, I have lowered them, but the performance gets worse because the RDWR timing actually gets even worse, and it starts causing even more training issues. So yeah, those are just on 4. CKE1, proc ODT auto, because the motherboard actually does a perfectly good job of setting like the ODT on its own. Gear down mode disabled, which is how I have CL15 working. If you're trying to run odd latencies on your Ryzen CPU and they're getting converted to even, it's because your gear down mode is enabled. If you have gear down mode enabled, you can't run odd timings, or you can't run odd cast latency, cast write latency. There's like a few timings that are affected by it and some that aren't. So like TRCD isn't affected. TRCD can be like which is why like this kit actually has an XMP of 3600 1415. Like it's designed for Ryzen. So 1415 with gear down mode enabled is fine. But 1515 with gear down mode enabled is not fine because that'll turn into 1615. And if you don't, and gear down mode is enabled by default, so if you don't disable it, the memory kit basically would be going from 15 to 16. So it's part of why it's 1415. They could have, I guess, also made it 1414, but the problem is TRCD like low TRCD is also a memory controller limit a lot of the time. So yeah, which I mean, like, that's the thing is, like, I actually have TRCD 14 at these crazy settings right now, right? But yeah, TRCD is often memory controller limited, so pushing it low can lead to stability issues. Anyway, then we have CLK drive strength. All of these are just set to 24, which is actually the same value that you'd get if you just left it on auto. And then nominal, write, and park. I forgot that these were set, but this apparently works. So yeah, that's that. The board actually defaults to this on auto. So I don't think there was a good reason to set these. It's just kind of there. I think it's a leftover from one of the other memory profiles I have on this board, and when like that just transferred over when I was making this profile. Anyway, other settings. VDDG CCD 1000. Actually, that's the issue with this board is I believe, or at least this BIOS version, I think, yeah. So this is the problem with this BIOS version and why the Infinite, like like it's not doing it right now. Like it's not done it in this take, but in some of the past takes, the system would just randomly cut out because for whatever reason, the board insists on manually setting the VDDG for you, and it goes to 1050, which is too much on the CCD side of things, and actually perfectly acceptable on the IO die side of things. But basically, the CCD voltage, generally you want to be below 1000, and the IO die voltage, like there's no reason, like I've not seen instability due to too much IO die voltage. I have seen instability due to too much CCD voltage. So yeah, it's super annoying that on this motherboard the independent VDDG voltage controls aren't working properly. Anyway, SoC voltage 1.2, which we already went over. FCLK 1900, VDDP 1150, necessary for memory settings this aggressive. And then all this other stuff is auto. Also, you might be wondering how I got all of these settings over here, because they're normally buried in the Gigabyte BIOS. The way you do that is like, say the VDDG voltages. So you go into like AMD overclocking here, go to your VDDG voltage controls, and then you hit insert, and you get this little star, and that star is how you get them moved into your favorites. So if I wanted to pull, say, and you can do that for any setting, I think, anywhere in the BIOS. So if I wanted to move Q-Flash to my favorites, I hit insert, and there's Q-Flash, right? And if I want to remove it, I hit insert again, and it's gone. Bye-bye. So yeah, that's kind of all I wanted to show you. That's a bit about memory overclocking on the master. Well, more like benchmark overclocking than like raw frequency, right? Like I already did a raw frequency video with this board. So yeah, these Teamgroup sticks, really good, really good. Now I kind of like I still think that right now they're like I don't think the sticks are maxed out in this current configuration. I think like that's the motherboard's maxed out. So I do plan to actually mess with these on another motherboard pretty soon. Hopefully we can get some even better settings out of them. Actually, when I pull out the 4750G, that should give these sticks wings. Because the thing is, I can't even train above 4800. Like I've tried like 4933 with looser timings. It doesn't work. Um, so yeah, this 3700X isn't taking these any further, but I have some you know, more like now I have a CPU that theoretically might be able to do like 5000 at CL14. And I should have a motherboard that's also capable of that kind of thing. So anyway, yeah, that's it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. Also, thank you to Teamgroup for sending over these memory sticks for me to play with here. And there will be more videos about them. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me directly. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. There's a link to that down in the description below as well. And that is it for the video. So thank you for watching and goodbye.